Today we'll review rational exponents from freshman year, as well as introduce some new things regarding this topic. If you remember, rational exponents are exponents that are fractions, and what we can do with these rational exponents is when we have a denominator, we make that the index of our root, or the thing inside the radicand, and then we have our numerator to be the power of the base. Now we can also write this similarly as the denominator's index of the number, and that whole quantity can be raised to that numerator's power. And once again, we call b the index of the root. So in these two examples, we're going to simplify these expressions without using a calculator. So since I can't really recognize the value of 16 to the 3/2 power, I'm going to change its form to this guy right here. So what I'll do is I'll say, well, that's the same as the square root of 16, and typically I'm not going to write that square anymore, all to the third power. Square root of 16 is 4 to the third, which is 64, and that's my answer. Likewise over here, I can say that's the fourth root of 81, all raised to the third power. Well, multiplied by itself, 4 times gets you 81. That's 3, raised to the third, which is 27. Now we have a negative exponent here, and we've studied that before. We know that that means take the reciprocal of 27 and raise that to the 5/3 power. So we have the cubed root of 1/27 all to the 5th. Well, multiplied by itself 3 times gets you 1/27. That's 1/3. And that's raised to the 5th power. And then we need to take 1/3 raised to the 5th power. And I believe that's 1/243. Now this problem is going to be a little more difficult because I have a radical and I also have a rational exponent. Now to deal with this, I want to make sure I have everything in the same form, so I'm going to change this radical to a rational exponent. So this is 1/8 to the 1/2. The index on this guy is a 2. So, moving forward, I now have this expression, and I know I have a power raised to a power. I can do this a couple of different ways. I think I'm going to bring the 8 up to the numerator, which means that I'll say that's 8 to the negative 1/2 power. Remember, taking the reciprocal of something means making a negative exponent. And that's all raised to the negative 2/3. So when I multiply a power of a power, I end up with 8 to the 1/3, which is the same thing as the cube root of 8, which is the same thing as 2. Now we're going to take and simplify this term in radical form. Well, what I have is I have 9 to the 1/4 and y to the 2/4. Now, y to the 2/4 is going to reduce to 1/2, and the problem I have here now is that my denominators are different, so I can't make one radical out of that. I can reduce this 9 to the 1/4 by expressing 9 a different way. We know that 9 is 3 squared, and that's raised to the 1/4. Now notice what that's going to do. Since I have my laws of exponents, which say I can have a power of a power and multiply those powers, this goes to 3 to the 1/2 and y to the 1/2. And since I both have 2's as my denominators, my index can be 2, or a square root of 3y. In this case, we're going to solve for x, and I have a rational exponent here. So I'm going to do this two ways actually. I'm going to do it with the rational exponents first, and in this case I have to get rid of this power. So in order to get rid of the power, I'm thinking, well, how do I do that? Well, I know that when I raise a power to a power, I can multiply powers. So if I want to get rid of 3/2, I'd have to multiply that by 2/3. So in this case, I take quantity to the 3/2 power and raise that to the 2/3 power. Now whatever I do to one side, I must do to the other side. The left side of this equation goes to x minus 4 raised to the first power. The right side goes to the cube root of 8 squared. So I have x minus 4 is equal to 2 squared, or x minus 4 is 4, so x equals 8. Now there's another way to go about doing this, and that would be to take and convert my rational exponent to radicals. Something like this. Now, if I want to undo a cubed, I'd have to take the cubed root to undo that. So notice, I could cube root this side, cube root this side, end up with 2 is equal to the square root of x minus 4. Then if I want to undo a square root, I'd have to square both sides, like so. This gives me x minus 4 is equal to 4 and x equals 8. Either way is fine. I typically will look to do the raising of the reciprocal power. So in this case we want to simplify this expression. Notice I have a 4 here and a 2 here. The only way we can add powers of bases are if the bases are the same. So in this case I'm going to make 4 equivalent to 2 squared, and that's raised to the 3x minus 7, and then 2 is just to the 7x plus 1. Power of power, I multiply powers, so I have 2 to the 6x minus 14 multiplied by 2 to the 7x plus 1. Laws of exponents say same base, add the powers, so this is 2 to the 13x minus 13. So you'll notice in this example I'm asked to multiply two terms with unlike indexes together, and mathematically we can't do that. So what I'll do is I'll change these radical forms into exponential forms. This goes to 8 to the 1/2 multiplied by 4 to the 1/3, and we're still out of luck because I don't have the same base. Luckily I can rewrite 8 and 4 as numbers of a base of 2. So 2 to the 3rd is equal to 8, and that's raised to the 1/2, and 2 squared is equal to 4, and that's raised to the 1/3. Power of a power, we multiply powers, so that's 2 to the 3/2, and this is 2 to the 2/3. Now we can take and add our exponents. So this is 2 to the 3/2 plus 2/3. I'm going to need common denominator. So I have 2 to the 9/6 plus 4/6, which is 2 to the 15 over 6. Now sometimes they'll ask us to leave these in exponential form, sometimes they'll ask us to put it back into radical form. So that would be something like this. Similar situation here. We have 1/3 to the 1/2 power, and we have 9 to the 1/5. Again, I need like bases. Well, these can both be expressed as a base of 3, so this is 3 to the -1, all to the half, and this is 3 squared to the 5th. Again, we multiply our exponents. And then we will now add our powers. We have 3 to the -1/2 plus 2/5. Get a common denominator of 10. So this is 3 to the -5/10 plus 4/10, or 3 to the -1/10. If they don't want negative exponents, that's 1/3 to the 1/10, or the 10th root of 1/3. That's all we've got for you. Make sure you do lesson summary and problems from Connect Ed lesson 42.